Video topic: the 2023 Super El Niño, how record-breaking Pacific warming triggered America's wildest summer and rewrote the weather playbook. In the middle of August 2023, sirens started wailing across the Salt Lake Valley in Utah, a place where almost nobody keeps a tornado plan taped to the refrigerator. The National Weather Service issued a tornado warning for the area, something that had not happened there in 10 to 15 years. And residents who had spent their whole lives associating severe weather with somewhere else suddenly found themselves staring up at rotating clouds over the Wasatch Front. It was a strange, almost unbelievable moment for a state better known for its ski resorts and canyon country than for chasing rotating supercells, a single alarm bell ringing out in the middle of a summer that, city by city, region by region, kept breaking its own rules. Around that exact same time, the desert Southwest was drowning in monsoon moisture pulled straight out of the Pacific. Flooding was showing up far farther north than it had any business appearing in mid-August. And Arizona and Southern California were baking under temperatures that were shattering long-standing records, some set decades earlier. None of it was random. Every single piece of it traced back to one enormous, invisible force building quietly beneath the surface of the Pacific Ocean. A climate pattern strengthening toward historic levels and about to rewrite the rulebook for hurricane season, for wildfire season, for agriculture, and eventually for the entire winter that would follow. That force had a name meteorologists had been watching, climbed the charts for months, and by the time it peaked, it would rank among the 5 strongest events of its kind ever measured on modern instrumentation. It was El Niño, and in the back half of 2023, it was gearing up to become something the climate world would be talking about for years. To understand why a single climate pattern could trigger tornado warnings in Utah, record heat in Arizona, and a strangely quiet hurricane season in the Atlantic all at the same time, you first have to understand what El Niño actually is, and how fundamentally different it is from its opposite twin, La Niña. Both are phases of the same underlying climate cycle, technically known as the El Niño Southern Oscillation, and both are driven by water temperatures in a specific stretch of the tropical Pacific Ocean. During El Niño, that water warms up dramatically above its normal range. During La Niña, it cools down instead. It sounds like a small, distant detail confined to one patch of ocean thousands of miles from the nearest American coastline, but that shift in ocean temperature reaches out and reorganizes wind patterns, storm tracks, and jet stream behavior across the entire globe. It happens roughly every 2 to 7 years, and it typically sticks around for 9 to 12 months once it gets going, though the strongest events, this one very much included, have been known to persist considerably longer than that before finally releasing their grip on the global pattern. And in 2023, it was not just showing up, it was showing up in a big way. By the middle of that year, sea surface temperatures across the tropical Pacific were climbing at a pace that stunned even experienced climate forecasters. Water temperature data, collected over just a couple of months, showed a dramatic, sustained warming trend. And the comparisons scientists reached for were not subtle ones. This event was being measured against the legendary El Niño of 2015 into 2016, a period remembered for an unusually wild winter and an unusually active hurricane season in its own right. As 2023 progressed, the comparisons only got more dramatic. By the time this El Niño peaked in the early months of 2024, the World Meteorological Organization confirmed it had become one of the 5 strongest El Niño events ever recorded, with sea surface temperatures in the key monitoring region sitting at or above historic benchmarks. Some analyses placed it in a virtual tie with the sea surface temperature values of the famous 1997 to 1998 Super El Niño, an event still used as the gold standard for comparison whenever forecasters talk about extreme versions of this pattern. Combined with the rapidly warming Arctic and record ocean heat building simultaneously in the Atlantic, this surge helped push 2023 into the record books as the warmest year ever measured on planet Earth. And forecasters were already warning that 2024 might climb even higher once the full effects of the pattern worked their way through the atmosphere. There is a specific mechanical reason a warming patch of ocean thousands of miles from American shores can reach all the way into a Utah tornado, warning, or a Texas heat dome, and it comes down to something meteorologists call teleconnections. The long chains of cause and effect linking ocean temperature to atmospheric circulation on the other side of the planet. Connections. Modern weather models are only now becoming powerful enough to map with real precision. Under normal conditions, trade winds blow steadily from east to west across the tropical Pacific, piling warm water up near Asia and Australia, while allowing cooler water to well up along the coast of South America. During El Niño, those trade winds weaken or even briefly reverse, and the warm water that would normally be stacked up in the western Pacific sloshes back eastward instead, spreading out across the central and eastern basin. That relocated pool of warm water becomes a massive source of heat and rising air reorganizes the position of the jet stream thousands of miles downstream, which is exactly why a shift in ocean temperature near the equator ends up dictating whether Kansas City bakes or the Rockies see an early season of snow. What made this El Niño so consequential wasn't just its raw strength. It was the specific, almost surgical way it reorganized weather across different parts of the world at the exact same time, sometimes producing dramatically different, even contradictory outcomes within the very same week. In the Pacific Ocean, that record ocean warmth acted like rocket fuel for tropical development. Storm after storm spun up across the basin, with multiple simultaneous areas of development at once: tropical storms, tropical depressions, and typhoons all forming in rapid succession. At one particularly wild stretch during that August, meteorologists were tracking 7 separate tropical systems churning across the Pacific Basin simultaneously, an almost absurd number crowding onto the same satellite loop. 2 of those systems, one drifting south and another drifting north, ended up close enough to interact directly with each other in a phenomenon meteorologists call the Fujiwara effect, where 2 spinning low-pressure systems essentially begin orbiting one another, sometimes merging into one larger system entirely. It's a rare enough interaction that most forecasters only get to point it out to their audience a handful of times in a career. And here it was playing out live, twice in the same summer in the middle of an already frantic Pacific season. That same year, the Pacific typhoon season would go on to produce Typhoon Mauer, a storm that intensified into one of the strongest northern hemisphere tropical cyclones ever recorded for the month of May, packing sustained winds over 130 miles per hour and a central pressure that plunged to 900 millibars, numbers that put it firmly in the upper echelon of storms ever tracked in that basin. Meanwhile, on the exact opposite side of the world's tropical weather map, the Atlantic Ocean was behaving almost eerily calm. By the middle of August 2023, the basin had produced only 3 named storms, a startlingly low number for that point in the season. This wasn't a coincidence. It was El Niño doing exactly what El Niño always does to the Atlantic. The same shift in global wind patterns that supercharges the Pacific tends to choke off the Atlantic, generating strong upper-level wind shear that literally tears budding tropical systems apart before they can organize, while also dragging in drier air that starves storms of the moisture they need to intensify. Forecasters watching the pattern in real time expected the season to stay muted, projecting perhaps 5 or 6 additional storms beyond what had already formed, a modest tally by recent standards. There was a persistent, nagging caveat attached to that forecast, though, one meteorologist kept repeating throughout the season. Ocean temperatures in the Atlantic were simultaneously running at record levels of their own, an entirely separate phenomenon layered on top of El Niño's usual suppression. That meant any storm that did manage to survive the hostile wind shear and find a gap in the dry air had an enormous reservoir of unusually warm water waiting underneath it, fuel capable of transforming a modest tropical storm into a major hurricane astonishingly fast if the atmospheric conditions ever lined up. That tension between suppression and raw potential energy defined the entire season, and by the time it wrapped up, the 2023 Atlantic hurricane season had still managed to produce 20 named storms in total, tying it for the 4th most active season ever recorded, a startling final number given how quiet things looked in the middle of August. Hurricane Lee emerged as the season's strongest storm, reaching sustained winds of 165 miles per hour and a central pressure of 926 millibars, powerful proof of exactly how much latent energy had been sitting untapped in those record-warm Atlantic waters the whole time. It was a season that essentially played out in 2 completely different acts: a suppressed, sluggish opening stretch through the summer, followed by a late surge, once a handful of systems finally found the narrow windows of opportunity that record warm water made possible, a pattern forecasters increasingly expect whenever El Niño and record Atlantic heat collide in the same year. Back on land, El Niño's fingerprints were showing up in ways that felt almost contradictory depending on which part of the country you happened to be standing in. Across the desert southwest, a stream of unusually moist air pulled up out of the Pacific dramatically amplified the region's summer monsoon season, an annual pattern of thunderstorms and rainfall that Arizona, New Mexico, and neighboring areas depend on every year. That moisture pushed flooding concerns much farther north than typically expected for the middle of August, catching some communities off guard. At the same time, a persistent warm tongue of ocean water sitting off the coast of Baja California helped drive temperatures in Arizona and Southern California to record-breaking highs, an unusual combination of extreme heat and heavy monsoon moisture operating in the same stretch of geography simultaneously. Further north and east, an entirely different story was unfolding. Strong northwesterly and westerly flow, itself a downstream consequence of El Niño's influence on the jet stream, helped keep the Midwest and Northeast running noticeably cooler than average for weeks at a stretch, even as Texas, Oklahoma, and the desert Southwest stayed locked in an unrelenting heat dome. It was a summer of true regional whiplash, one half of the country roasting under record highs, while the other half enjoyed an unusually mild, almost autumn-like stretch of weather. both outcomes driven by the exact same underlying climate pattern pulling the jet stream in different directions across different longitudes. That heat dome anchored over the southern plains and desert southwest proved to be one of the defining features of the entire late summer. Temperatures in cities like Dallas and Oklahoma City repeatedly climbed into the triple digits, and the relief that did arrive tended to be frustratingly brief, an occasional shower that cooled the atmosphere for a few hours before the heat simply reasserted itself the following day. Meanwhile, that same dome of high pressure effectively acted as a wall, deflecting storm systems and the jet stream itself away from the southern plains, and pushing the most active severe weather into the northern tier of the country instead. As August gave way to September, forecasters expected that heat dome to shift, drifting toward the central plains, the broader Midwest, and the Tennessee Valley, dragging the jet stream north along with it. That shifts at the stage for severe weather to reawaken across the northern plains and into the Midwest during the opening days of September, even as the heat itself simply relocated rather than disappearing, building instead across the lower Midwest, the Ohio Valley, and the central and southern plains, bringing drier conditions right along with it. Forecast models heading into that first stretch of September pointed toward temperatures running 25 to 30 degrees above average across a wide swath of the Great Plains, including Nebraska, Kansas, and Iowa. And by the following week, some of those anomalies were projected to climb even further, with temperatures 30 to 35 degrees above normal stretching from Oklahoma City all the way up into Minneapolis and Wisconsin. It amounted to one of the more dramatic late summer heat surges in recent memory across the nation's midsection, a stretch of days where entire states baked under conditions more typical of the peak of July than the tail end of August. A cold front was expected to eventually push through the northern plains and offer a modest, partial reprieve. But forecasters were clear that the core of the heat looked likely to hold on stubbornly across the Midwest and Central Plains well into the opening days of September, with cities like Kansas City and St. Louis expected to sit 25 to 30 degrees above their seasonal averages even as the calendar flipped into a new month. Beyond that point, the picture grew considerably murkier. Different forecast model runs disagreed sharply about what the second week of September might bring, some keeping the heat wave locked firmly in place well past the middle of the month, others hinting at a significant shot of cold air arriving right around that same window. That kind of model disagreement is common more than a week and a half out from any given date, but it underscored just how much uncertainty still existed even with El Niño's broad influence clearly stamped across the pattern. What forecasters felt considerably more confident about was the shape of the near term, expecting isolated to scattered severe weather to continue in the immediate future, concentrated mainly across the northern plains, with occasional spillover into the Midwest and Great Lakes region, while the building heat across the Great Plains would eventually have to break down, most likely through the arrival of a more organized storm system generating a broader round of severe weather sometime in the following 1 to 2 weeks, a pattern forecasters expected to repeat itself periodically as the calendar pushed deeper into the transition toward fall. There was also a genuinely striking possibility being flagged for the very start of autumn, snow across portions of the Rockies for the first time in a while, a signal some forecast guidance was hinting at for the first 10 to 15 days of September. It was the kind of detail that captured attention, specifically because it illustrated just how compressed and volatile the seasonal transition looked likely to be that year, potentially lurching from record summer heat directly into an early taste of winter conditions at higher elevations within the span of just a couple of weeks. None of this happens in a vacuum divorced from El Niño's broader influence. The entire jet stream configuration driving these swings, the heat domes parking themselves over specific regions, the storm systems being deflected north, the eventual breakdown of that pattern as cooler air worked its way south, all of it traced back to the same warm water sitting in the tropical Pacific, reorganizing atmospheric circulation on a scale large enough to touch nearly every region of the country in a different way. And that influence was never going to stop at the end of summer. One of El Niño's most consistent, well-documented fingerprints on North American weather shows up specifically in winter through a dramatic southward shift in the storm track. During strong El Niño winters, the polar jet stream tends to weaken and retreat northward while the subtropical jet strengthens and dips further south, dragging a parade of storm systems directly across the southern tier of the country instead of the north. Historically, this pattern has meant an unusually active, unusually wet winter across the Gulf Coast, the southern plains, and what meteorologists sometimes call Dixie Alley, the corridor stretching across the deep south that experiences an elevated risk of severe weather and tornado outbreaks, specifically during the cooler months rather than the traditional spring severe weather season most Americans associate with tornadoes. It doesn't mean the Midwest and Northeast get skipped entirely. Winter storms absolutely still reach those regions during a strong El Niño year. but the balance of active weather typically tilts hard toward the south and up the east coast, a pattern forecasters were already anticipating repeating itself as this particular El Niño moved toward its peak strength, heading into the winter of 2023 into 2024. The same southward tilt in storm activity also tends to reshape snowpack across the country in ways that matter well beyond a single ski season, typically favoring above-average snowfall across the Sierra Nevada and the southern Rockies, while leaving the Pacific Northwest and northern Rockies comparatively starved for moisture, a pattern with real downstream consequences for water supply and wildfire risk heading into the following summer. That expectation lined up closely with what actually unfolded. As the event peaked in the opening months of 2024, the World Meteorological Organization noted that El Niño conditions were continuing to influence climate patterns worldwide, even as the event itself began a gradual weakening trend, with forecasters projecting above normal temperatures across nearly all land areas globally between March and May of that year. The comparison to the 2015 into 2016 El Niño, the one forecasters kept returning to throughout 2023, turned out to be more than just a passing reference point. It was a genuinely useful roadmap. That earlier event, itself one of the 3 strongest ever measured at the time it occurred, produced a famously wild winter across the United States, and it arrived with its own dramatic hurricane season quirks in the years surrounding it, much like the pattern re-emerging in 2023. Looking even further back, the granddaddy of modern El Niño comparisons remains the 1997 into 1998 event, still widely regarded as the strongest on record and the benchmark every subsequent strong El Niño gets measured against. The 2023 into 2024 event landed in genuinely rare company alongside those 2 historic predecessors, cementing its place among the handful of truly exceptional El Niño episodes documented since reliable ocean temperature record-keeping began. What makes an event like this so consequential isn't simply the raw temperature numbers scientists track in a specific patch of ocean. It's the sheer breadth of downstream effects that ripple outward once that ocean warming gets underway. A stronger El Niño means a more dramatically suppressed Atlantic hurricane season, right up until it doesn't, since record warm background ocean temperatures can still punch through that suppression when conditions briefly align, exactly the tension that defined the 2023 season and ultimately helped produce Hurricane Lee's remarkable intensification. A stronger El Niño means a more energized Pacific basin, capable of spinning up simultaneous systems and rare atmospheric interactions like the Fujiwara effect that meteorologists don't get to point out to their audiences very often. A stronger El Niño means a jet stream configuration capable of producing genuinely bizarre regional contrasts within the same country at the same time, triple-digit heat baking one region, while another enjoys unseasonably mild conditions just 1,000 miles away. And a stronger El Niño means a winter storm track shifted so far south that regions rarely associated with major winter storm activity suddenly find themselves squarely in the crosshairs of an active, moisture-rich pattern parading in off the Gulf of Mexico. For residents across the southern tier of the United States, that shift carried very real practical implications heading into the winter of 2023 into 2024. Areas from Texas through the Gulf Coast and up into the southeast needed to brace for an elevated risk of significant winter storm systems, heavier precipitation totals than usual, and potentially a more active severe weather pattern than these regions typically experience once the calendar turns toward the colder months. Meanwhile, for the Midwest and Northeast, the expectation wasn't a complete absence of winter weather. Historically, those regions still see meaningful storm activity, even during strong El Niño winters, but rather a shift in emphasis, with the most persistent, most intense activity concentrated further south and east than an average year might otherwise produce. Farmers and water managers across the drought-stricken Southwest watch this outlook especially closely, since a strong El Niño winter has historically been one of the more reliable paths toward meaningful drought relief for California and the Colorado River Basin, even though forecasters were careful to caution that a single wet winter, however active, would not be enough on its own to erase years of accumulated water deficit built up across the region. Perhaps the most sobering thread running through this entire story is what it revealed about the interaction between a naturally occurring climate cycle and the broader warming trend layered underneath it. El Niño itself is nothing new. It has been cycling through the Pacific for as long as scientists have been able to measure it, alternating with La Niña roughly every few years, like clockwork. But when a historically strong El Niño arrives, on top of record ocean heat that already exists independent of the cycle itself, on top of a rapidly warming Arctic, on top of the warmest planetary background conditions ever measured, the resulting extremes stop looking like a routine climate cycle and start looking like something considerably more dramatic. Scientists have been careful to note that El Niño alone doesn't explain the full scale of the record warmth recorded throughout 2023, estimating that the cycle itself contributed only a modest fraction of a degree to the overall anomaly, but that El Niño's contribution was expected to grow substantially as its effects continued working through the climate system into 2024, essentially acting as an accelerant thrown onto a fire that was already burning. Eventually, as is always the case with this cycle, the pattern swung back the other way, with El Niño fading toward neutral conditions by the following summer and giving way to the cooler waters of an emerging La Niña, resetting the entire global weather stage once again for whatever pattern would come next. The 2023 hurricane season closing out with 20 named storms. Despite such a slow, quiet start in the middle of August, stands as a genuinely instructive lesson in how misleading a mid-season snapshot can be when a strong El Niño is actively suppressing storm formation in one basin while record ocean heat quietly waits underneath, ready to fuel anything that manages to survive the hostile atmosphere. The tornado warning that caught Salt Lake City off guard, the flooding that pushed farther north than expected, the triple-digit heat baking Arizona while the Midwest shivered under unseasonably cool northwesterly flow, the Fujiwara dance unfolding twice in a single summer out in the Pacific, none of these were isolated oddities. They were individual threads in one single sprawling tapestry, every strand traceable back to warm water, sitting in a specific stretch of the tropical Pacific Ocean, reorganizing the entire planet's atmospheric circulation in real time. By the time this particular El Niño finally faded into neutral conditions and eventually gave way to a cooling La Niña phase, it had already left its mark across an entire year of American weather. An unusually wild summer, a historically active but strangely front-loaded hurricane season, and a winter storm track redirected squarely toward the south, all traceable back to the same invisible engine humming away beneath the surface of the Pacific Ocean the whole time. It was, by nearly every measure meteorologists used to rank these events, one of the 5 strongest El Niño episodes ever recorded, and its fingerprints on 2023 and the year that followed will likely serve as a reference point the way 1997, into 1998, and 2015 and 2016 still do today, whenever the next great warming of the Pacific eventually begins to stir